I will demonstrate a Level 1 basic hardware application of oleumTech hardware, which includes a modbus master. We will use a software to emulate, a modbus slave, which we will use a DH2 with a black phantom antenna. Our end node will be an analog transmitter with a black phantom antenna also, which is connected to a transducer which has a 500-pound range. I will use a hand pump for pressure simulation. We will also use a USB to serial converter cable, our transmitter pigtail cable, and our DH2 configuration cable. Now we will move on to the Breeze configuration software. First, to configure any oleumTech hardware, you must have Breeze configuration software. If you do not have it, please go to www.oleumtech.com, use these instructions to download the software. Once you have the software, you open it, go to Edit, Options. Here you will set up your PC port, leave at 57600, none and 1, for those are the parameters of Breeze, and OK. Then we will start a new project, and we will name it. Today I will name it Analog Test. The 2.4 gigahertz checkbox is for overseas hardware only. The channel availability is up to 9. The group availability is up to 999, giving you many options. Set as you wish, but we recommend you dial away from each other if sites are closer than 2,500 feet. The bitrate defaults to 9600 and should remain there, however can be set at 115/200 if needed. The Enhanced Site Security checkbox should remain checked to preserve the integrity of your data and not allow sites to crosstalk, and then OK. Next, we will double-click on the name, right-click, go to Insert your first piece of hardware, a base unit or a DH2. Once inserted, double-click, right-click, and rename. Today I will name this DH2/RTU to signify that I am interfaced to an RTU. Then right-click, go to Properties, Edit. Set all parameters for DH2, starting with radio. Since there is a power supply available, you have the availability of setting up to 1 watt of transmit power. 1 or 10 mils should be sufficient, especially for testing purposes. Leave retries at 16. Go to Configuration tab. Configuration should remain at 57600, none and 1, for this is the port in the back of the DH2 that you come in with Breeze. Then go to the RTU tab. This is signifying the 6-pin Phoenix connector in the front of the DH2, which can be wired for 232 or 485. If using 485, check this box. You are a slave. You will ID the slave as needed. If you need extended registers, you will check this box. If you need to split 32-bit values in your RTU, you will check this box. Set the baud rate accordingly to whatever your RTU or PLC is. Today we will use 9600, none, and 1. And then click OK. Now you have set all the parameters of your DH2. We will move forward to insert your next piece of hardware. Double-click on DH2, right-click, and go to Insert, Analog Transmitter. Once you have inserted your transmitter, double-click, right-click, and rename. Today I will name this Well Tree to signify where I am putting said transmitter. Then double-click, right-click, go to Properties, Edit. Set up parameters starting with radio. Because this is a Div 1 battery device, 1 or 10 milliwatts is all that is allowed. We recommend going to 10 mils if distance is greater than 100 feet. Leave retries at 16. The node timeout is a modbus register that will flag if RF communications are dropped. So this is signifying that in 15 minutes the DH2 will change a modbus reg from a 0 to a 1 if data is not received. This should be set at 3 or 4 times greater than the reporting interval shown on the next screen. Today I will set this to 4 minutes. Then go to Analog Inputs. Here is the reporting interval of said transmitter. Today I will set it for a 1-minute interval. As I said, the node timeout is 4 times greater than the analog input interval. Then move to configure the analog input parameters. Double-click on AIN1. Name the transducer input. Today we will call it tubing. Select the units. You can use raw, voltage, or scaled. Today we will scale. The 0 in span is a 5-volt 0 in span from 0 to 5, default. We are using a 1 to 5 volt transducer, so we will move the 0 up 819 counts, which is 1 volt. We will move the span down from a 5 volt span to a 4 volt span by 819 counts, putting it at 3277. You can put in a bias if need be, and then the range of your transducer. Today we're using a 500 pound transducer, and then OK. If you are using a P2 or a P4, you can then set up AIN 2, 3, and 4 in the same manner. Once done, move to Exports tab. Here is all of the Modbus registers that are available within said device. You can move them from side to side to configure what registers you actually want sent in on the report interval from said transmitter. Today we want AIN1, we want battery voltage, and we want RF timeout. And then OK. Now that we have our transmitter parameters set up within our configuration file, we are ready to move to set up our Modbus list. Double-click on DH2. In the center window, go to Imports tab. These are the imports coming from the end node device. Click to highlight, shift-click, right-click, Modbus, paste to float table. Once done, go to Modbus table and confirm that they are there. 7001 through 7003. Tubing pressure, battery voltage, RF timeout. This is what you will request from your Modbus master, your RTU or PLC. This file is now complete and ready to be loaded, but first must be saved. Click the Save button or File Save. Today we will save it as Basic 1 Breeze. So we have a Basic 1 analog test Breeze configuration file ready to be updated to hardware. For the DH2 connections, you have a 6-pin Phoenix connector in the front for 232 or 485 communication wiring. The jumpers next to the Phoenix connector should be installed if using RS-485. You also have wiring for power and ground. The connectivity port on the back of the DH2 is where you would use to download your Breeze configuration. You also have the MMCX connector on the side for antenna connection. And that is all of the connection capability of the DH2. In order to download configuration file to your hardware, first connect your configuration cable from PC to the port of the DH2. Double-click on DH2, right-click, and click Update Device. If Site Security Mismatch comes up and asks you to reprogram the security key on the field device, yes, you do want to reprogram it because you have a new configuration file. Yes, we'll change the key. No, we'll not change the key, but we'll still push the file. Today we'll say yes. In the build window, the bottom of your Breeze configuration software, you should see download OK. If you do not, then it was not updated correctly. Connection to transmitter is a 3-pin flat for battery connection. It's a 4-pin flat for configuration cable connection. And the reset switch, which is located right next to both connections. Once complete with the updating process of the DH2, then move to update the analog transmitter. Using your pigtail with the 4-pin flat, connect to your configuration cable and connect to the transmitter. Then double-click on the transmitter in the tree, right-click, and click Update Device. In the Build tab, you should see Configuration Download OK. Then you know that each piece of hardware has taken its respectable download configuration file and knows its position. While still connected to the analog transmitter, double-click, right-click, and hit Connect. Once the connection window comes up, click on Analog Inputs, and then click Read. This should bring up a value that has our actual pressures, and in the blue bar should say RFOK, meaning the transmission was acknowledged by DH2. Then click OK. I will now apply approximately 100 pounds of pressure to the transducer connected to the transmitter, and then click Read again. As you see, roughly 95 pounds. Then OK. Now move to your Debug tab in the bottom and click Read again while monitoring your debug window. You see the transmission that is sent out to the DH2 and is acknowledged and accepted. You have now confirmed a local read. Click OK and OK to get out of the transmitter. Now move your configuration cable back over to the DH2. Now, with the cable in place between the PC and the DH2 and the debug window open, we can clearly see the RX packet Group 1 Node 1 with a length of 26, RSSI value of 50 has been transmitted to the DH2. We should see this happen every 1 minute because that is the interval that we have set. Now that we have confirmed data is coming into the DH2 at a good receive signal strength, we are ready to set up our modbus master to request said modbus registers. Today I will be using a software called Simply Modbus to emulate our request block. We are going to be asking for the first register of 7001. The number of registers is 3. Once you have your request block ready to send and you have completed your wiring between the DH2 and your RTU or Modbus master, today I am doing 232 and have wired to my Phoenix connector from my COM1 of my PC. So now I will send the request block. Notice when I do, in my debug window, I can see the response from the DH2. 7001, my pressure has bled down to 72. 7002, I have 3.6 volts, and 7003, I do not have an RF timeout. If I did, that would in fact be a 1. And every time that I send this request block, I see the response happen in the debug window. You can also clearly see that my modbus master has been populated with the proper registers in the proper location. We have now completed the basic 1 analog test Breeze configuration build and confirmed data all the way through debug and modbus master. And this can be easily accomplished with many different end nodes at one time.